Assalamualaikum warahmatullahi wabarakatuh. My name is Alisha Amira and we are from Group 3. We'll be presenting about materials used in corrosive environment. Corrosive environment is basically the disintegration of the metal starting from the portion of the metal exposed to the environment and spreading to the entire part of the metal. This is different from rusting. Rusting is a part of corrosion, but it is not the same. There are four factors that affect the rate of corrosion. Firstly is the increase in temperature, secondly is the increase in pressure, and thirdly the presence of salt or gases like sulfur dioxide, carbon dioxide, and fourthly is the increase in humidity. Here are the examples of corrosive environments, such as in marine environment, as the salt water contains salt, and in industrial condition as pollutions from toxic gases.
I am Afiq. I will explain the detail on the type of the material chosen. So we will choose aluminum corrosion. So aluminum is the second most abundant metal on earth, but for the excellent properties that lies on the aluminum, that is one of the most widely used metal today. So aluminum corrosion is low degradation of the physical and chemical characteristic of aluminum molecules into its oxide. Aluminum is both a reactive and passive metal by nature. Example of aluminum corrosion is galvanic corrosion, pitting corrosion, service corrosion, erosion corrosion, and filiform corrosion. So this is the type of corrosion, which is galvanic corrosion, pitting corrosion, service corrosion, and erosion corrosion. So for the galvanic corrosion, the aluminum may experience galvanic corrosion, also known as dissimilar metal, when it is physically or electrochemically coupled to a noble metal. For the pitting corrosion is surface corrosion process that appear as microscopic holes on the surface of aluminum metal. Service corrosion can be caused by overlapping material or inadvertent design flaws. For the erosion corrosion of aluminum is caused by impingement of a high-speed water jet on the aluminum body itself.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aisha Safira binti Abdul Rashid, and I'm going to present about the details on the physical properties of the material. The material that we choose is aluminium. Aluminium's physical properties refer to its apparent form and structure without any chemical modification. In terms of aluminium's physical properties, there are a few main aspects that need to be known. For the first one is color and state. Aluminium is a silvery white metal with a slight bluish tint and is also odorless and tasteless. For the next one is structure and surface. Aluminium has a face-centered cubic structure that is stapled up to its melting point. For hardness, ductility, and malleability, aluminium that is commercially pure is soft, but when alloyed and tempered, it becomes stronger. Aluminium also has a high ductility, which aluminium may be pounded to a very thin layer. And for the malleability, aluminium has a high malleability and may be shaped or bent. Next is the thermal expansion. The thermal expansion coefficient of aluminium is 23.2. This is the difference between zinc, which expands more, and steel, which expands half as much as aluminium. Next one is the conductivity. For the conductivity, aluminium has good thermal and electrical conductivity. Next is the corrosion. Aluminium is corrosive resistant due to a self-protecting oxide layer, which enables structure to have a relatively long service life, even when exposed to drastic climate changes, seawater and freshwater environments or chemicals. For the density, aluminium has lower density than any other commercial metal except for magnesium. And lastly, for melting point and boiling point, The melting point of commercially pure aluminium is approximately 660 degrees Celsius, while the boiling point is approximately 2470 degrees Celsius. When aluminium is alloyed, these properties change. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fizan Ahmed Rahman, and I will explain on the details on the mechanical properties and microstructure of the materials, which is aluminium. For the mechanical properties of aluminium, the first one is aluminium may be substantially distorted without failing, and it can be cast with a great degree of tolerance. And for pure aluminium, the tensile strength is approximately 90 MPa, but for some heat-treatable alloy, it can reach to 690 MPa. Next, aluminium is soft, strong, light, ductile, and also malleable metal. It is also a decent thermal, electrical, and also corrosion resistor. And the last one is aluminium is surprisingly harmless and theoretically 100% recyclable without losing any of its natural properties. Next, for the microstructure of aluminium. Aluminium and its alloy is weaker and less hard than many other metals and alloys. And aluminium is also a typical feature of ductile metals. Soft, and aluminium is a silvery metal with a face-centered cubic crystal structure. And the last one is a thin, transparent oxide film will form on a freshly polished surface because aluminium is extremely corrosion resistant. Next, for aluminium design limitation, the first one is aluminium lack in strength, which make it inappropriate for construction-related uses. Next, aluminium has a low fracture toughness, which make it unreliable in high-strength settings. And the last one is aluminium will not function well in a high-temperature environment. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Izzuddin Azizan, and I'll discuss about the fabrication methods and the applications of the materials. An aluminum fabrication process is a method used to form aluminum into a specific shape. There are 4 fabrication methods to form aluminum, including extrusion, casting, rolling, and forging. First is aluminum extrusion. In this process, a powerful ram pushes a heated aluminum billet through a die that has the desired final cross-section form. The resulting aluminum extrusion will have the cross-section of the die, which can have a vast assortment of form, including solid, hollow, and semi-hollow shapes. Next is aluminum casting. It is a process that is great for forming aluminum into very complex shapes. The technique involves completely melted aluminum alloys and injecting the liquid metal into a mold. The poured metal fills the empty cavity completely and then solidifies to create a perfect aluminum duplicate of the mold's internal shape. Then is rolling aluminum. The aluminum rolling process involves passing slabs of aluminum alloys through different sets of holes to reduce their thickness. This process repeats until the aluminum reaches its final form, resulting in a piece that will be considered a plate, sheet, or foil, depending on the thickness. Lastly is forging aluminum. Forging involves forming metal by pressing, pounding, or squeezing it to achieve the desired form. The producer heats a slab of aluminum and uses a press or hammer to change its shape. Parts produced by forging have great fatigue and impact resistance, thanks to the strengthening imparted by the processing technique. Next is application of the aluminums. Aluminum has been widely used and applied in the wool industry. Transportation mainly use aluminum due to the sustainable nature of aluminum with regard to corrosion, resistance, and recyclability, which has increased demand for aluminum vehicle components. Food packaging such as aluminum foil and beverages has resulted in the protection from corrosion. Aluminum has been widely applied in buildings such as roofing, fall insulation, window, cladding, doors, and architecture, however, as a corrosion resistance. That's all from me. Thank you.
In conclusion, aluminium is one of the material used in corrosive environment, as it is very corrosive resistant due to it having an protective oxide layer. It is also very famous to be used in the construction industry, as it possesses mechanical properties of being high ductility, high malleability, can be bended, and high thermal expansion. And due to the characteristics of extruded aluminium, which have high adhesive properties, the base metal surface also can be coated. And as a result, the base metal will remain corrosion and rust-free even the surface is damaged or scraped. Thank you.